what this is, how you would know to select this procedure. So let's pretend, if you could just suspend your disbelief a little bit, let's just pretend that example number 3 is like some question on some future quiz or test. It's totally out of context. You know, the previous question had to do with the net change theorem, and the next one is like a differentiability question. This is like out of the blue, right? How are you supposed to know what to do with this? So the first thing you'd want to do is look at your integrand and notice that your integrand is a product. And if your integrand is a product, that means you have at this point, pretty limited selection of things you can do. So if it was a product of like x times some polynomial, maybe you distribute the x. That would have been something pretty simplistic we would have done in the past. If that doesn't work, maybe you think about like a U substitution. Timmy messed up the chain rule, sort of a thinking process. And really, to be honest, that's sort of it, unless it's maybe like a trig function, like secant squared. Then I would just expect, hey, you know that the antiderivative of secant squared is tangent, that sort of thing. But you got this product, and the whole Timmy messed up the chain rule, U substitution is going to totally fall apart. The next thing maybe you'd notice is not only is this a product, but it's a product of what amounts to a polynomial times the transcendental being like sines and cosines and e's and ln's and that kind of thing. And as soon as you notice this right here, you got to think, oh, this is going to be integration by parts, aka the ultraviolet voodoo. Okay? So I'm hoping that would be kind of your process of how do I select the right thing to try with a question like this. That makes sense? I think that background thinking, like thinking about what you're thinking, is quite important. Okay. Any questions on that? So we've gone through all that in our mind, and we're like, all right, now we're going to do parts. So I'm going to erase my mind here, and I need a bigger eraser to erase my mind. There we go. So now, if it really is going to be integration by parts, we need to remember that the format for integration by parts is this: U times dV equals ultraviolet voodoo. UV minus the integral of V du. Alex, I'm trying to approach your question here as well. So what we want to do then is we want to use intelligent substitution to make this match up with that. So in this case, the U has to either be x or e to the x. And once we select what our U is going to be, then dV is going to be everything else in that integrand. That make sense? So the way that I set this up is I'm going to say my U is something, my dV is something, and I'll give you some, let's look at the two options. Like you could say that your U is e to the x, and your dV then would have to be everything else. So if I did say that U is e to the x, then dV would be what? X dx. When I say everything else, I literally mean everything else. Please don't write too big here. So then once I've, and really, honestly, there's reasons for picking what you pick, but literally all you're doing here is you're saying this goes here and that goes there. And as you gain more experience, you'll quickly start to realize what the right place is for the right sort of thing. But maybe if you're feeling inexperienced and you just have no idea, you just take a guess and you try it. So then we also, of course, in order to fill out the right side of this formula, I'm going to need not just a U and a dV, I'm going to need a V and a du, right? To fill out that formula, which comes from the product rule like I showed you. So if I want a du, that is essentially the differential of U. So that would be, well, gosh, the derivative of e to the x, just e to the x, so that's not a very difficult one to do. But then to go from dV to V, what am I going to have to do? Yeah, antiderivative, for sure. So V equals, well, this is going to be 1/2 x squared. So then we take this and we say, all right, well, let's plug this into the right side of that formula because this equals the thing that we're trying to find. So ultraviolet would be 1/2 x squared e to the x minus integral of voodoo. So that would be 1/2 x squared. Whoa, it's the same thing. Interesting. Okay, so obviously this left part over here, that's nice. But then when you look at the right side, what's going on with that right side? Because we still got to evaluate that antiderivative. Still got to actually do that. So what kind of a technique would we use for that?
Would that be another?
Isn't that another integration by parts? Which is not necessarily the end of the world. So let's see here. No, you guys are like, no, actually it is, in fact, the end of the world. Okay, so I need to remember that this is part of my answer. And I got to reset my u and my dv, right? So u equals and dv equals. So I'm going to just be working on this part. So for that part right there, which is, yes, another integration by parts, what would my u be? Well, why would you do that? Because before we made the u e to the x.
But it's resulted in a spiral, so.
Oh, you just use the key word. Check this out. Are you guys watching? Let's say we didn't think about that. And let's say we just did this again. We said, hey, you know what? Our u is e to the x before, and that got us somewhere, so let's do it again. Therefore, our dv would be 1/2 x squared dx. Think about what happens here. Wouldn't your du, once again, be e to the x dx? But what's my v? So this is, remember last time I mentioned there's a potential to have like this death spiral where you're like, my math brain is like not handling this, right? Because did you notice that the degree on the polynomial is going up? And it's just going to continue to go up until we do something about it, right? And you'll never finish this, and you just keep, like your answer will just go from here to here to here to here to here. It's never going to work. So, you guys want to know the answer to this? We unwisely picked at the very start, didn't we? So what I've got to do here, this is why I said write small. I got to erase all this stuff or cross it out or something. And I got to go all the way back to my beginning. And you'll get good at realizing this. Don't panic. And I want my, well, no. I'm going to say that my u has to be, oh, yeah, you're right. Yeah, your u has to be x. And your dv has to be e to the x dx. It's got to be everything else.
He's going to be just e to the x.
So yeah, v, this is an easy antiderivative. It's just e to the x. Du is just going to be dx. This is going to work out nicely in one step. So now we go to our ultraviolet voodoo. So it's going to be x times e to the x minus the integral of voodoo. And wow, check this out. That's actually a super easy antiderivative, right? The antiderivative of e to the x is just e to the x. So my final expression here is just going to be with a plus c tagged on the end, and I'm done. So do you see how picking the right thing could make all the difference, Emma?
What if, so like the first one, we did u equals e to the x?
Yep.
Or well, we did du equals e to the x, whatever. And then what if like the second time we did it during like the spiral thing?
You flipped it?
Yeah.
Then you're just creating more steps for yourself, but you would eventually cycle down to an answer.
Okay.
It would. It would just, in the end, you'd be like, oh, if only I would have picked the right way.
Yeah.
But it should
Okay.
cycle back down.
If you just keep flipping back and forth, will you just like that?
Yeah, we'll come back and see you when you're like 94 and you're like still doing the same question. So
I'll get there someday.
please don't do that. Yeah, we'd be impressed by your work ethic, but that's about it. Okay, you guys good?
I'll do my
Okay.
Pascal's triangle all the way out.
Again, we'd be impressed by your work ethic. We'd question your sanity, though. Hey, guys, on this one, is our class end at 10:20? 10:25? Okay, this is going to work out perfect. So, number 4, don't write large. Okay? Don't write large. So, the pattern is this, guys. Like, as you start to realize this and see this, the pattern is, unless there's a natural log involved in this situation, you really ought to always make your u the polynomial and make your dv all the other stuff. But if ln is involved, you got to reverse that. So you go through, you recognize this is a product between a polynomial and a transcendental, and so parts would be probably a viable solution here as far as the method goes. Josiah?
So with most of these problems, should you only have to do the ultraviolet voodoo once?
That's not a guarantee.
Okay, 'cause, like, at what point do you realize, like, oh, it's just gonna keep going?
If
or
the
maybe it'll
degree
go,
on the
like, a
polynomial is going up, 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 right? So if you did ultraviolet voodoo like 2-3 times, and you're like, man, I started off with like x to the 2, and now it's x to the 3, and now it's x to the 4, and now it's x to the 5. I must have made a mistake somewhere. It should be cycling down.
Okay.
Okay, so based on that, I would say that our u would need to be x cubed, and my dv would have to be all the other stuff. Brandon, your question?
Just like in general for transcendental functions, that's just like all the logarithms.
Yeah, logarithmic, cosine, exponentials,
Okay.
inverse trig. Yeah. Okay, so based on that, then du would equal 3x squared dx, and v, nicely enough, would just be sine. Guys, you want to be super duper careful here. Realize that when you go this way, you're doing an antiderivative, and so the antiderivative of cosine is positive sine. It's easy to think that you're doing the other thing when you're really doing what you're supposed to be doing. So, all right, so then ultraviolet voodoo with this would be x cubed sine of x minus the integral of voodoo, which would be sine of x times 3x squared dx. And this is where maybe a little bit of panic might start to rise up in you a little bit, right? Because you're like, whoa, okay, oh no. You look at this, and what do you see? You see another integration by parts? So you might be tempted at this point to say, oh, I must have messed this up. The truth is we didn't. Here's what we do. We keep going, and you'll see a pattern here in a second why keep going is the right choice. So I'm going to remember that x cubed sine of x is part of my answer. So I'm just going to come up here and I'm going to write equals or arrow x cubed sine of x minus, right? So I'm just taking this and I'm transferring it up to there because I know that's part of my answer. But now I got some more work to do on this other parts. Make sense? Okay. So now I'm going to reset my u and my dv. So now u would be 3x squared, and dv would be sine of x dx. Therefore, du is equal to 6x dx, and v then would equal what? Negative cosine of x. That's right. Okay. So now I'm going to use ultraviolet voodoo again. So this would be negative 3x squared cosine of x. There's my uv. Minus voodoo. Integral of negative cosine of x times 6x dx. And I guess you could do that. But even if you do that, don't you quickly realize that the integrand over here is what? Isn't it another parts? Now, at this point, the panic is like up to your chin, right? You're like, oh man, I'm wasting my time. But here's what you got to notice. Did you notice that the polynomial started off at degree 3? Then it went to degree 2, and now it's at degree 1? That's a good sign. We're heading somewhere that's going to finish versus not. Yeah, we would like to finish this. So then I know for sure then that this is also part of my answer. So I'm going to put this up here as minus 3x squared cosine of x. And now I think I've just got one more step to do here. So that would look like this. I'm going to come up here and I'm going to reset my u and my dv. My u would be 6x. My dv would be everything else. cosine of x dx. All right, so then that means that du now is just 6 dx, and that's kind of our hint that we're about to finish, right? The fact that du does not have an x with it, that hints to me that we're about done. And then v would be sine of x. Make sense? So then I'm going to do ultraviolet voodoo one more time. It'd be 6x sine of x minus the integral of 6 sine of x dx. So finally, that integrand is not a parts integrand, right? It's actually a pretty simple one. The antiderivative of sine is negative cosine. So this would end up being 6x sine of x plus 6 cosine of x. So then those last two pieces go back into my answer line. So up here would be plus 6x sine of x plus 6 cosine of x. And after all that, please don't forget plus c.
Cute.
Yeah, it'd be easy to forget the plus c.
Why was it positive on the second?
So what I did there, Brandon, I did minus, minus. I pulled the minus out and made it a plus. I do, before I get your question, Jasmine, I do have some good news for you. You could obviously simplify that a little bit. The good news I have for you is when I see you tomorrow, we are going to talk about example number 4. Example number 4 says, could have been more easily done, and by more easily, I mean way easier, you'll see it, by something called tabular integration, which kind of goes along with this integration by parts thing. So we'll look at that tomorrow. Your question?
Does our whole thing have to be in parentheses?
Yeah, because, so the reason why, Jasmine, is I'll highlight this in a lovely purple. This minus sign is that minus sign, and everything that results here came from this. That makes sense? So yeah, you distribute that minus sign throughout the other terms.
But you put the minus, like if you didn't switch the sign on the cosine, and then just do like another nested parenthesis.
Yeah, you could have handled the minuses a little bit differently, for sure. It would have been inside, like you said. Yeah. Okay, guys, have a wonderful day. Thank you. Look forward to seeing you all tomorrow.
And then derive it off.
And you can check it out by just doing a nice derivative. It'd be 1, 2, 3 power rules. Thank you, Jeff. And some like term combining, and I think you'd get there. Thank you. See you later.